Okay, so today's about patterns and linear functions. So first vocabulary word, dependent variable. Okay. Your dependent variable changes in response to another variable, the output. Usually your dependent variable is y. When you have an equation that has both y and x, y equals 4x plus 5, y would be your dependent. It depends upon what your x is, what your y is. You choose the x, the y is determined by what x you use. That is why it's called the dependent variable. It depends upon the x you pick. Y depends upon x. Okay? Your independent variable doesn't change or depend upon another variable. It's the input. This is usually your x. You get to choose the x. You put x into the equation, it spits out y. X is independent, that's chosen. Y is dependent because it's determined by what x value you choose and the function you have. Okay. Like I said, it's usually x and y, but other variables also work. A function is a relationship that pairs input and output with exactly one output. So for every x, I only have one y to go with that x. That's a function. I put in an x, I get a y. They pair up. Anytime I have x and y pairs, I have a function. Okay. A linear function is a function whose graph is a line, but not vertical. Vertical lines technically are not functions. Horizontal lines are. Any other angled straight lines are linear functions. A vertical line is linear, but it's not a function. Okay. I'm just scrolling up. Okay, and what we're dealing with in this chapter is we're dealing with linear functions. We're going to do a lot of linear functions in this chapter. A lot of graphs, a lot of equations are all linear. Okay, we're not going to deal with nonlinear ones. Other than say, oop, that's not linear, we're not going to work with it. Okay? So, this is typically, I've seen this is described as a function machine. What you have is you have your input. Your input is x. And then you have some function, something that you do to that x value. Okay, and then out comes f of x or y. Y and f of x essentially mean the same thing. Two ways of saying the same thing. F of x is a function of x. Y is another way of saying a function of x. The more advanced you get in math, the less you use y equals, and the more you use f of x equals. Okay, my calculus students do a lot more function notation. F of x, g of x, h of x, a lot less y equals. They still do it, but they do less of it. Okay, function notation has really good uses. Eventually, you'll do more and more of that. Okay, so for example, I have a function machine next to it. My input is 3. My function is 3x plus 1. So this is my x. My function says I take x, multiply it times 3, and then add 1. So if I take 3, multiply that times 3, and add 1, I get 10. 3 times 3 is 9, plus 1 gives me 10. I put in 3 into the function, I multiply that x times 3, and then add 1. And the next one. My x is negative 2. My function is to take x and square it. So I take negative 2 and I square it. What's negative 2 squared? Positive 4, because a negative times a negative is a positive. So I get 4. So on the last one, I don't have a function. I don't have an x. I don't have an output. So here's what I want you to do. Pick a number, stick it in here for x. Pick an x. Pick an easy number.
2.
Write it down. Pick a number, any number. Write it down. Put it in your circle, any number you want. Okay, everybody in here, it's entirely possible everybody has a different number. I say pick an easy one because you want to make it easy on yourself. You know, 3.5 is not an easy number to work with. 2 is a very easy number to work with. Pick a function. 2x plus 1, 3x minus 5, 4x, x squared minus 2. Any function. Come up with some equation you want, something to do to x. Write it in the box. In theory, everybody in here will have a different one.
Are we actually?
Yes, you're actually doing this. I told you to do it. Do it. Pick a number. Write the number down. Pick a function. Write it down. And then put x in the function and get your output.
Where do we write it down there?
Put the x, put the function, put your output. Remember, this is being recorded. Everybody just heard you ask, what are we doing?
Hey, what are we doing?
Okay. So, question. This is good because I like this because this works the idea of a function. I take an x, I stick it in there, my y is out. This is the independent variable because you get to choose what number goes here. This is independent. You got to pick this number. This is the dependent variable because what number you got out depended upon what you stuck into the machine. Okay? You got to pick what goes in. What goes out is determined by what's in here. Okay? That really explains independent and dependent variables. Okay, now this is where things are going to get a little goofy here. You got to pay real close attention on how we set this up.
Oh my God. Yeah.
Okay. So, representing a geometric relationship. Okay. Guys. All right. In the diagram, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent the relationship in a table, in words, an equation, and a graph. Okay, so we're going to work through this together. We'll start with the table. Okay. In the first figure, how many rectangles do I have? I have 1. That is my x value. I have 1 rectangle. Okay. In there. Now, my perimeter is 2 times 6 because what do I have over here on that side? I have another 6, right? Because rectangles are the same on both sides. So I have 6 and 6. Every single one of those. Notice that every single one of those rectangles have a 6 on one end and a 6 on the other. That's why the 2 times 6 is always the same for every single one of them. Now the other one is 2 times, because I have 1 on top and a 1 on the bottom, they add together to give me 2. 2 times how many rectangles I have. How many rectangles do I have? I have 1 rectangle. So that perimeter of the first one, 2 times 1, which is 2. 2 times 6, which is 12. 2 plus 12 is 14. This is my x. This is my y. The perimeter is my y. My ordered pair is 1, 14. Okay? My ordered pair is 1, 14. 1 because I have 1 rectangle. 14 because that's the perimeter for 1 rectangle. Now, how many rectangles do I have in the second figure? I got 2, so the number of rectangles. So my x is 2. Now the formula, the stuff that's in black never changes. Stuff that's in black for my formula never changes. It's the same for every single one of those. It's 2 times the number of rectangles plus 2 times 6. So it's 2 times the number of rectangles. In this case, my number of rectangles is 2 plus 2 times 6. 2 times 2 is 4. 2 times 6 is 12. 4 plus 12 is 16. So my XY coordinates, 2, 16. Are you seeing a pattern here? How many rectangles in the third one? 3 rectangles. My Y, I still have the same thing. 2 times how many of rectangles plus 2 times 6. It tells me my perimeter. Two times how many rectangles did I have? 3. Okay. 2 times 3 is 6. 2 times 6 is 12. 6 plus 12 is 18. So I have 3 and 18. See if you can fill in the last one on your own. Fill in the bottom row. See if you can fill in the bottom row on your own. Okay, so how many rectangles do I have? 4. What's my perimeter? So 12 plus 8 is 20. So my coordinate is 4 and 20. Okay? Question so far. This is one way to represent that relationship. You can almost always in math represent things in more than one way. This is a table. Another way to do it is in words. Okay? This one's a little bit harder, putting it down in words, what we're doing here. Okay? So the perimeter of each figure is, I should say right, is 2 times the number of rectangles plus what was I adding every time? 2 times 6, which is what? Plus 12. You do not need to write out the words 2 and the numbers 2 and the numbers 12. You can use 2 and 12. You don't have to write it out in words. I'm just doing that to make it words. Okay. Yeah, so the perimeter is 2 times the number of rectangles plus 12. Because that's what we did every time. We did 2 times the number of rectangles plus 12. Now, to write it as an equation, because making an equation makes it work easier. The perimeter was, if you look at the table, the perimeter is y. So y is equals, the perimeter y is equals 2 times the number of rectangles, which is 2x, 2 times x, plus 12. That's my equation that describes it. Okay. Last one. Plot your points. One rectangle, I basically plot my pair here on the graph. This is the number of rectangles. This is the perimeter. So one rectangle has a perimeter of 14. Two rectangles has a perimeter of 16. 3 has a perimeter of 18. And 4 has, oops, I was off on that one. 18 and 20. If I connect the dots, what do I get? I get a straight line. Thus, a linear equation, because it gives me a line, a linear line. That's where it comes from. Okay, it gives me a linear equation. Questions?
No, sir. I fixed myself.
Your turn. Same thing, but let me help you get this started. Because the figures are a little bit harder. The number of triangles is x. So how many do I have in the first figure? 1. How many do I have in the second figure? 2, and so on. So that's my x. That's easy to do, right? The perimeter, the formula, is a little more difficult. Here's what I want you to do. Eyes up front. Look at this, or you can look at the one on your paper. It doesn't matter. In each figure, what remains exactly the same? What numbers are exactly the same in each figure? I have a 4 and 3, but okay. But which ones are the same every single time? What one doesn't change? What one does change? The 3s are the same. I have 2 3s in every one of them, right?
Yeah.
3 and 3, 3 and 3, 3 and 3, 3 and 3. What does change? The 4s. So it's just like the previous one, the way it sets up. It's 4 times the number of triangles, sorry. I should not put that in there. So it's 4 times, whoo, uh-oh, that wasn't good. I didn't want to do that. So I don't need to write it down because it's already up there. So your perimeter, your formula is 4 times the number of rectangles plus 2 times, so 4 times the number of rectangles plus 2 times 3. And what are you going to do every time? You're going to fill that in. Just like the previous one. 4 times the number of triangles plus 2 times 3. 4 times the number of triangles plus 2 times 3. So the number of triangles goes here, put it in, figure it out to get your y. There's your ordered pair. Okay? So take your time. Fill in the table first. And then try to do the best you can on writing it out in words, coming up with an equation, and graphing it. You should be able to do the table and should be able to do the graphing without too much problem. But see if you can do the rest of it as well. Okay, so take a couple of minutes and do that. Okay, let's go ahead and do this. So the first one, the number of triangles we have is 1. Put 1 in here. 4 times 1 is 4. 2 times 3 is 6. That gives me 10. So I have the point 1, 10. 2 triangles, put 2 in here. 4 times 2 is 8. Plus 6 is 14. So I have 1 and 14. 3 triangles, 4 times 3 is 12. 12 plus 6 is 18. So I have, that's 2 and 14, 3 and 18. 4 triangles, 4 times 4 is 16. Plus 6 is 22. Thank you. I was adding it in my head wrong, and I know I was getting the right number. Somehow I was doing the right number. Okay. So in words, the perimeter. 4 times 4 is 16. 16 plus 6 is 22. Okay. So, guys. Okay. in words. The perimeter is 4 times the number of triangles plus, and what did we add each time? 6. Transferring the words to an equation, that's easy. Perimeter, we used y for our perimeter, so y equals, because is equals, 4 times the number of triangles, that's 4x, it's 6. Get over it. Plus 6. Okay? And then plot the points. So I have 110, 214, 318, and 422. Questions? Okay. Representing a linear function. Pay close attention because we're only going to do this example. I don't think, nope, that's it. But you're going to have several problems like this on your homework, on your classwork. Only the one example to go from. So the table shows the relationship between the number of photos you can take and the amount of memory left on your camera. Is the relationship a linear function? That's the first question, and that's an important question. It's easy to figure out, though. How much does the number of photos increase by each time? Goes up by what? When I go from here to here, how much do I go up by? From here to here, I go up by. From here to here, I go up by. These are all the same. Makes it easy. Now, here I don't go down. I don't go up. I go down. How much do I go down by? 3. I go down 3. I go down 3. Listen closely. If these are all the same and these are all the same, it's a linear function. If these are all the same and these are all the same, it's a linear function. Now, if these are different, if these aren't all 1s, but they're all 2s or all 5s, doesn't matter. Now, the other way to tell is to take this difference, divide it by that one, if I get the same number each time. So if I take -3 divided by 1, -3 divided by 1, and then take the next pair, -3 divided by 1, and take the last one, -3 divided by 1, I get the same number each time, right? So if they're not 1, 1, 1, 1, or 2, 2, 2, 2, you can still do the same thing by taking each number on the y, dividing it by the one on the x every single time. If you do that, you get the same number. It is still a linear function. And this is the important number here. What do I get when I divide them? I get -3. This is very, very important. There are 2 numbers that can be really important for figuring this out. This number here and this number here give you your equation. That gives you your equation. Because that's the hardest thing to get, I think, is the equation, figuring that out. And it's really easy when you have this. Okay? It's going to be y equals. How much did I change by each time on the y? What was the change? When I divided it out, what did I get? -3. So it's going to be y equals -3 times x. And then when this is 0, I have plus whatever that number is. Plus whatever number goes with 0 in the table. That's my equation. Okay, that's my equation. Now, what's going on in words? the memory decreases by 3 megabytes for each photo. And then plotting the table, plotting the points. You got the table, you got the graph, plot the points on the table, on the graph. When x is 0, y is 512. When x is 1, I get 509. When x is 2, I get 506. When x is 3, I get 503. And I plotted 503 wrong.
Yo, messed up.
Yeah, I do that. But you know what I do when I mess up? I fix it.
Fix it. How did I know that?
Okay? Everybody messes up. What you do afterwards counts. You mess up in life, everybody makes mistakes. It's what happens when you make mistakes. It's what you do afterwards, that's what counts. Okay? So, questions. Okay, you're gonna be able to have to do this with just this example on several homework problems today. And yes, I want the words, I want the equation, I want a graph. It asks for those, I want those. I don't see those, you don't get full credit for those. Okay, just trying to be perfectly clear.